Hey guys, welcome to episode 24. This is the P2P network coding session. And at this episode, we are going to code, um, we are going to solve the problem we left unsolved at the previous one. That was that the social entity maps that are loaded inside the network node when we start the social graph service should also be loaded at the client side because we need them in order to get the available storage as part of the integrating this with the open storage project. So let's check. Um, let's check where we were working at. Okay, here. So remember that we remove the loading of this stuff from the app bootstrapping process into the social graph network service. Okay, because we thought this is more appropriate, which it is, but at the same time, at the same time, we put it depending only of this network service. Okay, so how are we going to deal with this? Most likely I'm going to okay, so all this is based on this information, and this is located here. So I need to move this code inside of SA. It can be a module inside SA, but not the social graph peer-to-peer network interface. Mm. Okay, so which would be a good name for this? Um, this was app bootstrapping process. Let me check the network. Oh, just realized that I haven't switched to the code view, sorry. So I was looking here of this code and just thinking where I should move it, okay? Um, so yeah, um, if I see the network workspace, well, I have a lot of stuff that doesn't belong here. This is the network workspace. Okay, this is a APP bootstrapping process. Maybe I call it the same because essentially that is what it usually uh, I usually do for consistency. So I'm going to create a similar stuff in here. So new file.js. Okay, so at the project schema, we have this bootstrapping process, and this is the education project, the network project, and the social trading project. Not at NT, but SA. We will add not at social graph, but here we will add an app bootstrapping process. Okay, but here the name is going to be new social trading app bootstrapping process. Okay, so we have this guy and we have this guy. We're going to copy it here, but we're going to use this function name here. And there's probably not going to be anything of this. So I would just delete all this. And for all apps that needs to operate with the social graph network service. Okay, so this process is going to do only a few things, and the things it's going to do is everything that we have here. That essentially is load social personas and social trading bot. Load social personas and load social bots. Oops. Okay. All right. So I don't need this guy, and at this process, so to finish the connection, we're going to use this guy. or this guy. So here we are still going to run this, but this is going to be the so what we're going to do is this dot run. Okay. So something similar to this we will do the web app interface. This is not very super clean. Um, it's not super clean. Um, but still, we can do this here or either inside of this, but I will do it right now here. Um, I don't even need to keep a reference to this. I just need this process to run. Okay, so this would create the this map that we need in order to get the social entity, and from there the available storage. Okay, so before we accumulate more stuff, we're going to commit this maybe bootstrap process for social graph implement. Okay, so theoretically we can now save a post using the open storage project. Theoretically, Let's see what we need to do to retrieve a post from the Open Storage project. So when we got a query, and the query is one of these types, the post text, we are going to get it from get post text. What we're going to send here is the event file key. Because that's all we need to retrieve a file from open storage. Okay, so get post text. I'm sending the file key. So okay, so we already have a promise here that we might want to return it just here, because we don't need even to return it later. Also, I like the idea of having a function like this. So we don't need this. Okay, anyway, this is not going to last because you're not fetching this in this way. Okay, this is load post async, load post async. So we're just going to delete all this and we're going to code again the get post text function. This function is say pod storage. Then this one should be load post from storage. Okay, and we're going to put these two functions together. Okay, so here we go again. We got a file key, and what we are going to do is to see at the GitHub storage how do we load one file. Say one file, load one file. So what is the context of this? Okay, so it seems control if the file was not already loaded, because the same file can be stored at multiple storage containers for resilience. So we will have a file loaded by ID map. But this is not our case because With the first file stored, we were aborting and recording that file only. Hmm. So I'm thinking about this, if we are going to have multiple storage or not for posts. Because for trading signal it makes sense, for post, not sure. Um, so for now, probably not. It just gets too complex. So the way to do this, saving the post at multiple places, would be counting the amount of files that we try to save. Save count. Save count is 0, okay? Save count is 0. I could do like this. I increase save count here. And then create an extra function. All files, save it. Okay. So instead of sending this message back, I can do So here I increment saving, and here I increment save it. Here I don't increment anything. But then I check if saving is equal to this, then all file save it. Okay, but for this to work well, we will need if available storage equals 0, then response error because storage container references is 0. Okay, so what were we? So if we could save this, then if saving count gets to the number of the array length, then it means that we all files save it. Okay, then here we do similar, but we are not going to count anything. Just if saving count is equal this, all files save it. Then we need at least, we also need a file key array. Let file keys and array of file keys. Okay, and this implementation is even better than a trading signal, because in trading signals we are sending only one file key, and if that file key is not available, then nobody knows where else to get the signal. Okay, so I'm going to write here trading bot trading signals, take a note, send an array of file keys instead of only one file key. Okay, so I can say the signal at 3 different places, send you the locations, and you know that with one of those available you will get the signal. So it's super resilient. Okay, so we are going to implement it at the here at the posts, so you can have 2 different repositories or 2 different containers in general, and if one is not available, maybe the other one is. Okay, so file keys is going to be an array. So every time a file is saved, we're going to push to this array with file key. I'm going to push this. Okay, good. So if the file is not saved, we're not going to push anything and just check if we reach the end of the array. So at file saved, we're going to ask if I could save at least one, okay, file saving count more than 0, this means a success. Otherwise, we fail to save at least one of these one of these files. So if it is a success, if it's not a success, we're going to say sorry, but and this promise status we will not need it because we are not with the possibility of having a reject more than one. So error storage provider failed to save at least one file. Okay, rejected. But if this is good, then we are going to say this, but without checking this or this or anything. Okay, so at the same time, we are going to move these guys to the success side of the story that is here. So if saved count is greater than 1, origin post hash equal file name, blah blah blah, and then we will do event dot file keys going to be equal to the file keys array. And just like that, we're going to resolve. And now we have the possibility to store the post in multiple containers spread across the internet. And remember all this. So there are a few things I have to change. I will have to change not only events. Where was I touching that? Here? No. Okay, events. Events is one, but also I need event. Event, posts, and events. And also we will need from the social graph post. So what is all this? Okay, let's start for events. Event. Event. I don't need query. Follower. I need post. Maybe post reply. Following no. Event post and follow no. Query validations no. This no. This no. And this no. So the client interface. We'll let this go through. Web of interface done not here. Okay, so file key. We're going to put a limit on file key. So as to prevent the attack that might happen if somebody creates a file key with a huge amount of information, like any number of nodes. We're going to be checking the rate, also the size of the event. Probably there is no need for that, but we have to be conscious that we will have to check not only the rate but also the amount of bytes at each event that we receive. Because the amount of byte will allocate memory to store in that event. Okay, so I'm not going to control and put an arbitrary limit on the file keys because it's going to be arbitrary anyway. So what we do is to check for file key and replace it by file keys, because now it's going to be an array. Okay. Okay. Then the post also is going to have file keys. Okay, so here there is a query where you ask for so there is no signal stuff, but there is file keys. Post replies. Okay, file keys. Okay, so with this we upgraded. Okay, I'm a little bit lost now. we upgraded the save post as storage. Okay, so we upgraded the save post storage with multiple file keys. Okay, so now now we have this guy. Save at user storage. No. Okay, now we are here again, and we're going to check how we did this with the open storage project. Here, loading a file. Uh, okay. Okay, so let's say that this is what is going in here. Mhm. So we're sending the array of files keys. So we're going to declare this here. Okay, then we are going to iterate the files keys array and try to load one by one in the order that we have the array, essentially. Okay, so what we're going to do is I'm not sure that we need this here. Why do we need? I don't. I'm not sure I even need a map because if I'm going to do an await and get encrypted file content, then the file content is going to decrypt this with the password. We will need network global storage container by ID. And I guess we will have this. And then so what happens inside this GitHub storage load file? Probably I need here let me think about this. If I receive a rejection, this is going to crash. So I need this to be with error handling. But let's say I have the error handler. So I need to count, yeah. This would get a rejection if I cannot read any of the storage stuff. Okay? Probably not a rejection, but I can resolve in all cases with a response with a specific response. Content not available at the moment. Okay, so I will need this to work like this, and then I load it, catch, file not loaded. Okay, so we will do here also file content, and we don't need this map. I think so. File content loading count loaded count equals 0. So we do the same trick. Every time we are going to be loading one file, we add this. Every time we're going to create a few functions here. Function on file loaded. Okay, um, so no parameters here. So if file not loaded, if we have on file loaded, then we can just resolve. Oh no, we are not going to resolve. I'm going to do like this. Function all files loaded. So it's the same trick. If we're going to, the file content is the same at every place, so it doesn't matter if it is the first or the second, everything goes to file content. Okay, we're going to say file loaded count, add one more one. So if how do we know if we need to stop? Here's something tricky, because it should be if loaded count plus not not loaded count equals this array length, then that means that we finished because these are the answers, not the requests. Okay. Loaded count, not loaded count. If this equal this, then all file loaded. The same would be here, but not loaded count. So if I content um, file content is not undefined, that means that the response is going to be okay. Post added. We are going to send the content, file content. Okay. And result is not okay. Post not added. And that's it. We are going to resolve anyway. Okay. So the trick here is that we don't use counting, but this. And this guy here, loading, is not needed because we are going to use the loaded count and the not loaded count. We know that to end this, we need them to be equal to file length. So if we receive a content, this is going to be different to undefined, so we respond this with the file content inside there. Otherwise, but the guy is looking for a file for a content directly, so I don't need this. And here we will post content not available at the moment. Okay, post content not available at the moment. And this is how we load any of the, in fact, we try to load from all the places at the same time. We don't even wait and see. Well, maybe we should wait and see. But since this is asynchronous, what should I do? Um, mm, my question is, why would I try to read another storage location if I already had content? Why? But the thing, I am forced to use a catch. If this call doesn't work, then I have to use it then. So maybe it should be another way. Um, if one file is loaded, then I can resolve with file, but I cannot return unless I do here if file content is not undefined, then not here, but here. So we're not going to execute the rest of the loop if we already have a file content. So that means that if we have it, then we can decrypt the data, have a file content, and resolve with the file content. So if the not loaded equals the file key length, then I can resolve with the content not available. So I will accept a file not loaded, a second file not loaded, but if the third file is equal to the amount of files, then I will resolve with this. And probably we are going to put file content, so this is going to be set into this variable, which is going to prevent the looping, which, to be honest, it shouldn't continue looping because we already counted up to the amount of this, so this is not needed. Okay, so the first file loaded will prevent the other tries, and it's going to be good enough, and resolve with that. In the last one, not loaded, we'll resolve with this. Okay, so I want to check this logic here. We are saying here is saving count equal this. This means all saving, all files saved. Because we're counting every time we try to save. This is not good. Because maybe I counted 3, I send a request, but comes file not saved from the first guy, and it will be 3 equal to this, but it's not true. So I need to count, not saving, but save it and not save it. So this is not correct. On file save, we count this. On file not save, we count this. So if save it plus not save it equals that, then we should stop. Okay. So this is all the code we need. So to recap, at this episode, we have moved some logic that was at the initialization of the social graph network service to a module, a bootstrap module that is run from the initialization of the social graph network service, but it's also run from the user interface, from the web app interface module. That is something that is going to be a little bit reorganized still, but it's also run that bootstrap process so that we have available some memory maps that we need. Also, we code in this episode for the post to be saved in multiple storage containers, and to be retrieved from multiple storage containers. Um, so to make it like as much resilient as it can be. You see. So it's impossible to censor or even to not have it available. You can add 10 different storage container all over with different multiple storage providers. The information is going to be encrypted there, and all the five keys are going to be attached to that event or to the post. So whoever wants to open that post can retrieve from 10 different storage locations, and it's going to try one by one until it can open the file. And once it opens, stops, and it shows you the information. So this is probably the maximum resilience we can have. So I'm very happy for that. I'm going to debug this at the next episode. So thank you for watching, and see you at the next one.